Welcome to The Explainer. Today, we're going to pull back the curtain and meet the incredible, world-changing heroes of our digital world, the algorithms of machine learning.
Okay, so let's just dive right in. You gotta understand, at their core, humans and computers have always had this one massive difference. We learn from experience, right? We adapt. But computers, well, they've traditionally just been really good at following a script, a set of instructions. That's it.
So that brings up this huge, fascinating question. What if computers didn't have to just follow orders? What if we could actually give them a superpower, the power to learn, just like we do?
Well, the answer is a huge yes, and that's exactly what machine learning is all about. It's the science of teaching computers to learn from patterns without having to write code for every single little thing. And for a computer, that experience we keep talking about, it has a special name. We call it data. All right, let's meet our first hero. I want you to meet the predictor. Its superpower? Forecasting the future. And in the machine learning world, this power is called linear regression.
So, let's make this real. Imagine you want to sell your house. You need to figure out how much it's worth. You know its size, and you have a bunch of data from other houses that have sold. So, how do you make an educated guess for your place? This is where the predictor just shines. It looks at all that past sales data, all those dots on the graph, and it draws the one single line that best captures the trend. And boom, just like that, it can take the size of your new house and give you a really solid prediction. In this case, $120,000.
So how in the world does our hero find that one perfect line out of a gazillion possibilities? It goes through this training process called gradient descent. And the best way to think about it is like our hero has to carefully climb down a mountain made of every possible mistake. We can call it Mount Everest. And this whole process is just so cool. Check it out. The computer literally starts with a wild guess, a totally random line. Then it measures its error, which is just how far away its line is from all the real data points. Now, step 3, this is the magic. It nudges the line, just a tiny bit in the direction that makes it a little less wrong. And then it just repeats. Measure, nudge, thousands of times, until it finds the one line with the absolute smallest error possible.
But, you know, the world isn't just about predicting numbers. A lot of the time, it's about sorting things out, bringing order to chaos. And for that, we need a whole team of specialist heroes, the classifiers.
Our first classifier is basically a probability expert. It just learns from what it's seen before. So, for example, if it sees that 80% of past emails with the word cheap in them were spam, it creates a simple but really powerful rule for the future. This is the hero that's working inside your spam filter every single day. But things get more complicated, right? For tougher challenges, like trying to decide who gets into a university based on grades and test scores, we need heroes that can draw a really clear line between a yes and a no.
And this slide just illustrates two awesome heroic styles perfectly. On one hand, you have the ninja. It makes a fast, efficient, good enough cut to separate the groups. But then you have the surgeon. It is meticulous. It finds the one single perfect cut that creates the widest possible gap between the categories. And that wide margin, that's the key. It means the surgeon is way more confident in its decisions, especially when it sees something.
Okay, but what happens when the data is just a complete, tangled mess? I mean, what if no straight line, no matter how clever you are, can split the two groups apart?
Well, for this exact situation, our heroes have an amazing team-up move. It's a secret weapon called the kernel trick, and it's pure genius. If you can't solve the problem on a flat map, well, you just add a whole new dimension.
By literally lifting the data points up into a 3D space, what was an impossible, tangled mess in 2 dimensions suddenly becomes, well, simple. Now, a basic flat plane, think of it like a sheet of paper, can just slice right through the data, and our heroes can finally make that cut. So cool.
Now, our final hero's power isn't about predicting the future or sorting the present. It's about finding hidden structures in the data, patterns that we never even knew were there. This is the organizer, an expert in clustering, and its power is absolutely fundamental to how modern companies understand their customers. So here's the challenge. You want to open 3 new pizza shops in a city. Where do you put them to best serve everyone? You have all the customer addresses, but you have no idea where the natural neighborhoods of pizza lovers are.
The organizer uses this brilliant looping method. It starts by literally just dropping 3 random points on the map. Then it assigns every single customer to whichever parlor is closest. Next, and this is the key, it finds the new center of each of those customer groups and moves the parlor right there. And then it just repeats that whole process over and over until the groups stop changing and, bam, the perfect locations for our pizza parlors are found. It's the same power that helps streaming services figure out what kinds of movies you like.
So we've just met this whole league of machine learning heroes. And the crazy thing is, they aren't off in some distant future. They're already here, working silently all around us, every single day.
So let's do a quick recap of our hero league. We've got the predictor, forecasting the future. We've got the classifiers, who bring order to the present. And we have the organizer, who reveals these hidden patterns in our world that we could never see on our own. Look, these aren't just fun comic book characters. These algorithmic heroes are actively shaping your world right now, from your email to your shopping recommendations. So the real question isn't just, what will they solve tomorrow? It's, what problems do we want them to solve next?